Amsterdam. 800,000 plus residents. 500,000 plus registered addresses. 100 fire incidents per week. 19 fire stations. How can we manage fire risk? What is the effect based on neighborhood features? How do we plan fire risk inspections? And which venues do we focus on? Our neighborhood-based effect module is able to answer these questions. The neighborhood effect-based module consists of a dashboard where grouping can be made of the selected venue type. The module can be applied on a wide range of venues and busy areas. However, the chosen application is on petrol stations. The probability of a fire incident in a petrol station may be small, but the effects will be gigantic for the neighborhood. Let's take a look at that.
Hoe een grote brand leidt tot een blijvend litteken in de stad. Dat is te zien in Eindhoven. 6 jaar geleden vloog daar het Tem Oil tankstation in brand en de buurt kijkt nog steeds tegen een kale vlakte aan. Dit zijn de beelden van toen. De brand ontstond waarschijnlijk in de winkel van het tankstation. Ook de naastgelegen winkel met motorkleding vatte vlam. De flat boven die winkel stond helemaal vol rook. 22 bewoners moesten geëvacueerd worden en de flat raakte zo beschadigd dat die moest worden gesloopt.
As you can see, the effects can be huge. Therefore, the neighborhood effect-based module will act on top the currently existing framework that the municipality of Amsterdam is using. In this way, the current calculation of the probability of a fire incident can be extended with an effect score. The effect score will indicate the magnitude of a fire incident on the surrounding neighborhood. Based on the experience and expertise of the fire inspectors, the effect score can be adjusted accordingly. The effect score is a weighted average where the weights can be adjusted by the user. For the calculation of the effect score, neighborhood-based features will be used. The features could be both static and dynamic. Static features are the petrol station characteristics, for example, the type of fuels the station offers and whether its shop is open 24/7. Most of the dynamic features originate from the Google API and are chosen based on the vulnerability to fire incidents. An example of features could be the number of hospitals, schools and elderly homes, but also whether there are residential and business areas. As mentioned before, the neighborhood effect-based module consists of a dashboard. In this case, the dashboard will show all the petrol stations located in Amsterdam. On the right side, we see the map of Amsterdam with the pinpointed petrol stations. On the left side, we see the user control pane. There are 2 main user inputs, 1, the radius around the petrol station, and 2, the feature weights. Once the radius is set by the user, the dashboard will adjust its calculations of the number of, for example, schools and hospitals. The higher the radius, the more counts may be, and the lower the radius, the less counts may be. Grouping of the petrol stations will be done based on clustering machine learning algorithms. Once the controls are set, the effect score will be calculated and the petrol stations will be grouped. Each group is indicated by a color. The goal of this solution is that the location points are grouped by its feature similarity. This helps by prioritizing and planning fire inspections. The second goal is that it calculates a weight-based effect score. These functions make it possible to optimize fire inspections and assess the risk in a more sophisticated way.